All right, everyone, please welcome Evren, who's going to talk about putting the graph back in GraphQL.
Thanks, Bill, and thanks for joining, everyone. So my name is Evren Sirin. I'm the CTO and co-founder of Stardog. And today I'd like to start with giving a little bit background of where I'm coming from, what Stardog is doing, which will give you a better understanding of how we are approaching the graph in general and GraphQL specifically. I'm not an expert on GraphQL. You guys probably know more about GraphQL details. So I'd like this to be a open conversation. As I said, if you have questions during the talk, please feel free to put them in the chat and we can pause and have a discussion. So Stardog is both the company and product is called Stardog. It's an enterprise knowledge graph platform. The main problem that we are tackling is data silos in large enterprises. Our customers are typically from Fortune 500 large enterprises that have lots of data, lots of databases spread all around the organization in different departments, and all the databases are locked in their silos, not connected to each other. And this causes problems as you try to make data-driven decisions. You'd like to unify those data sets together for maybe a machine learning task or for some kind of decision support system. You'd like to be able to query all the data that's spread within the organization. And we don't focus on a specific industry. We work with financial banks and so on, or pharmaceuticals and so on. So the graph technology is very flexible for any domain. And we use, our customers use it to solve different problems in their respective domains. As a company, we founded the company in 2016. I and my co-founders have been working on graph-based technologies since early 2000s. We met at University of Maryland at the research lab there, and started actually working on the Stardog product before we started the company in 2016, raised our round. We are relatively small, 80 employees. Spread across the world, United States, Canada, Europe, and Asia. So we've been distributed from day one. I'm in the Boston area, the company headquarters in the DC area. Yeah, you might tell from my t-shirt, Celtics. I'm excited for the NBA Finals game tonight. Yeah, let me talk about the product a little bit and what we are doing to solve these data silo problems. So what Stardog provides is a semantic data layer that will go over the data spread across different data sets. It could be like the snowflakes, oracles, MySQLs. Relational databases are very commonly used, as you know, but also some NoSQL databases, Cassandra's, MongoDBs, or there could be even unstructured data within a data lake kind of architecture. So our goal is to connect these data sources and enrich that raw data with some semantics and context. Because one thing we see over and over again is, especially if you have like a data lake architecture, there's a lot of raw data stored in there. Someone goes in there, first it's hard to find the data, then you find it, clean it. It's hard to kind of reuse that information that's kind of locked in within one project, and it's not in a reusable way, all that work that goes in. So instead, what we provide is this graph layer, which adds this additional metadata into these data sources without necessarily moving the data. So one different thing that we do compared to graph databases, if you are familiar with them in general, we don't necessarily move the data into Stardog, and we have a virtualization layer where we can expose the data that's in these relational or NoSQL databases as graph data and translate the graph queries on the fly to whatever query language is supported by data sources. And there's also an additional inference layer built into the platform. So the graph structure kind of gives you this additional semantics and metadata, as I mentioned, but then you can add some additional business logic as part of your graph to define new relationships within that graph, and that will help you to detect patterns easier, reuse those patterns, and get additional insights. And what I'm talking about right now might be a little bit too high level, but I'll spend most of the time today actually showing you things in action and how these things work in Stardog and how it connects to GraphQL. So at that point, let me kind of talk about GraphQL. I assume most of you already familiar with it, so I didn't put like what is GraphQL kind of slide, but just talk about some of the benefits GraphQL provides in general, which compared to REST-like architectures that came before it. You get better performance with GraphQL. This is something that's keeps coming up in general, because in a REST kind of API, you need to always get a large payload as a result of your REST call, even though you might only need a subset of the data. So with GraphQL, you can ask for exactly the information you need, not the extra stuff. You can minimize the round trips that you need to do. Instead of talking to multiple REST endpoints, one GraphQL query can bring information from multiple parts of the domain. A strictly typed interface in GraphQL means there's less ambiguity about what types you are dealing with, especially compared to REST and so on, where you would rely on human readable documentation to understand what kind of data is needed. You get like built-in API documentation as a benefit of those strictly typed interfaces. And it's also easy to use GraphQL to fetch data from many sources. You can have a single schema where the fields are pulling the data from different data sources, and everything is exposed as one single schema. So as I said, like what we are tackling with Stardog is these data silo problems, trying to pull information from multiple sources and return it to the users. So GraphQL kind of provides that benefit out of the box as well, because you can have those resolvers that you can implement to pull the data from different data sources. But then there's a problem with this kind of approach, because as a result, you might end up when you run a GraphQL query, the client sends a single GraphQL query to the server, but the server itself might have to run lots of database queries as a result to pull the data from those data sources. And it's a little bit hard to optimize these queries because every resolver runs in isolation. They fetch the data, the joins and everything needs to be done outside the system. So there's less opportunities for global optimizations for GraphQL queries. Typically, you need to do some kind of coding to make changes, like you need to register a new resolver if you want to add a new field, or if you want to make changes. Sometimes it could be a configuration change, but it's still a little quite like developer heavy process making those changes. And also, if you have different GraphQL schemas that have been developed independently, there are solutions like stitching GraphQL schema so that you can have a single schema. But that's not very straightforward. There are some issues making it work in the real world, and it requires a little bit more work to combine those independently developed schemas to work together. So what we are doing is, with Stardog is kind of different than what you would see in a regular GraphQL system. Like if you take something like Apollo server or whatever you have to implement a GraphQL architecture. So what we are doing is we are starting with a graph model in the first place. This is not a GraphQL schema, but I'll show this. I mean, there's a lot of overlap between the graph models we use. And we are using a standard called RDF, Resource Description Framework. This is a graph data model standardized by W3C to represent graph structures. So that's the core of our platform. Then we can map this graph model to external data sources. So the mapping process is not implementing resolvers, but mostly defining how the nodes and relationships in a graph would correspond to like tables and columns in a relational system, for example. And then at the third step, we expose this RDF graph model as a GraphQL schema. So you can run GraphQL queries against this model, which behind the scenes will use the mappings to pull the data from those external sources and return the results to the user. So at this point, I will switch to showing you a demo to make these things a little bit more clearer. So I'm going to go to Stardog Cloud, which is the main portal we use for interacting with Stardog. And there are three separate tools you see here. I'll go through them as we go through the demo. We'll start with Stardog Designer, which is where you create that data model that I mentioned and define your mappings. Then Explorer is for kind of visualizing the contents of the graph, the instance data. So Designer is more the schema data model. Explorer is about instances. And Studio is kind of an IDE where we can run queries and handle configuration. So let me go to Designer and show you an example of a model. So I have several different projects. I'll go to this demo model that I've started creating and talk about this. As is the custom with GraphQL, we have a demo based on the Star Wars demo you've probably seen in the many GraphQL tutorials around the web. Some version of Star Wars data being used. So I have something similar here. So I'll maybe zoom in a little bit to show you what's here. So each node you see in this graph is representing a class in the RDF jargon, but in the GraphQL world, this is what you would call a type. So a character is a type. It has relationships in the GraphQL world, fields that connects it to other types. So a character, for example, is linked to species type through this species relationship. A character might be a member of an organization. And then you'll see also some special kind of relationships between classes. So pilot is a subclass of character. So this is like the standard class inheritance relationship. Here, if I move to, for example, spacecraft, you'll see that spacecraft has different kind of subclasses. One is warship, which has additional subclasses that you can see if I can just. So this is kind of, as I said, a standard class hierarchy representation. I will talk a little bit later about like how these things map to GraphQL, but right now what we are looking at is basically the visualization of this GraphQL RDF graph model. Let me also select this class, for example. The attributes associated with classes, these are the basically the primitive valued attributes associated with those classes. So characters have like birth year, eye color, hair color. Spacecraft has like attributes that are relevant for spaceships and so on. So this is the model, and just to make it clear, I mean, you can make any changes here. Let's say, I don't know, I'll add a different kind of class, for example, battle cruiser as a subclass of the warship. So you can kind of make changes to your model here, easily create these mappings, create some additional relationships. For examples, I can select the pilot model and say pilots are linked to spacecrafts through the flights relationship. So we can create this model in a visual way. And this is still kind of just metadata, right? It's a data model, there's no instance data. And at this point, I'll start bringing in some data sources. And maybe just to give you the information, so if I switch to Studio, I have already created connections to two data sources. One is a MySQL database running locally on my local host. And I'm also connected to a Databricks based relational database. Let me double check. Okay, it seems it's still working. Databricks has a habit of pausing the SQL endpoint. So it seems to be working now. So I created these. This is kind of a very straightforward process. Just you need to give some credentials, provide the URL and things like that. But once you have that connection, you can bring that data source into this model. So I'll connect to my MySQL database and pull information from this relational database that has information about Star Wars characters. So I'm going to name this characters MySQL. Here you see kind of a preview of the information. And once I add this resource, it shows up as the table in my model. Now I can define mappings from this relational database to my graph model. So I'll select the database here. I'll say create a relationship. So this will be mapping the characters. So I'll call this character mapping. And I will be, okay, I need to get rid of this thing. So I'm having problem moving things around here. So I'm not sure if you can see well, but basically I created a link from this MySQL database to my character class in my graph. Then I can map these fields from the relational database to my graph model. So I select the primary identifier that will be used to identify the nodes. And then I can map any of the columns. So there's a height relationship here, for example, height attribute or height column in the relational database. I have a height attribute for characters. So I can say these two things correspond to each other. So this is what I mean by defining mappings. We don't need to write any code. We just need to define the equivalences between these columns in the database and these relationships in the graph. So, but you also see there's, for example, a column in the database that says home world. So this is connecting a character to a planet. And here we have this home planet relationship. So what I'd like to do is create a home planet mapping that will connect that column from the database to this relationship in my graph model. So we are mapping the home planet relationship in the graph model. We will use that home world column from the database, and that's it. So this is kind of, this is what you would have typically as like a foreign key relationship in a database that turns into a relationship in the graph. Maybe I'll pause at this point to make sure everyone is following what's going on, if there are any questions. That's if something is not clear. Okay, I don't see any questions. I'll quickly kind of switch to this view to save some time, where I have done this kind of mapping, not just for these characters table, but also the planets table. This one is coming from Databricks. But I can also use these mappings to pull data from CSV files. So the starships is, the information about starships is coming from a CSV file. So here we see the preview of the CSV data. So we can map the information from the CSV file into the graph as well. With these mappings, once I publish this model to Stardog, what happens is the CSV data gets saved as graph data in the database, but these mappings to the external databases, they are created as what we call virtual graphs. So we don't pull the data from the external database, but we create these virtual graphs that we will be able to query as if all the data is stored in Stardog. So yeah, I have already done the publishing here. So basically just select the target of where you want to publish this model and mappings. So I'll just switch to the studio view to show you what happened. So as I said, there are some behind the scenes, as I mentioned, like we are using RDF and RDF related standards. So some of these mappings we automatically created. You don't have to worry about the details of those things. But the other thing that we do is we create a GraphQL schema automatically from that RDF model as well. So here, when I switch to this GraphQL schemas view, you see that the classes that we were looking at that model, they show up as types in the GraphQL world. They have their fields connecting them, like both the attributes, but also relationships from types to other types as well. So all of this information is auto-generated from that graph model we put together. And what this allows us to do, if I now switch to the graph, the query view, I can now write a GraphQL query against this database, which will pull the information from wherever the data is being stored. So let's run this query. Let's see. Oh, actually, the Databricks endpoint might have a been paused. Okay, so this is going to take a while. As you can see, the Databricks database was paused, so now it needs to start. Maybe while it's starting, I'll talk about what's happening behind the scenes a little bit. So maybe I'll create a new tab here. So when I'm running a GraphQL query like this, what happens behind the scenes is Stardog will look at these types, and then we'll look at those mappings that we have defined and figure out how to answer a query like this. Actually, I can show you the query plan, which will look very foreign to you, but I'll just, when I look at the query plan, what happens is we see the Sparkle representation of this GraphQL query. Sparkle is the standard query language for RDF. So we translate this GraphQL to Sparkle first, and then create an executable plan out of this. And you'll actually be able to see like there are some SQL queries we generated automatically based on this query, because the mappings that we have defined allows us to figure out which database we need to access to and what fields we need to pull from. So let me go back here. Okay, as you can see, it took almost 1 minute to execute this query, but once the database is up, it's going to be quite straightforward. Okay, so the character data, as I said, it's coming from Stardog. It's stored in Stardog. This is coming from the external database. I can obviously add additional fields to pull more information. So let's grab the climate field from the planet. But there are also some built-in directives, GraphQL directives that you can use to filter the data. For example, I like to find only the planets where the climate is temperate. So let's fix this. So these are, again, straightforward to tell what this thing is doing, but this is, there are lots of built-in functions that comes with RDF that you can use. So here, as you have noticed now, the query, instead of 88 results, now we are seeing only 38 results because the planets have been filtered. And you can add, instead of equality, for example, we can use the contains, because a planet might have multiple things. If you are seeing all these error messages, if I try to execute when something is selected, it tries to, oh, okay, I just mistyped the function name. It should be contains. Okay, now we got 48 results because there are some planets that has, for example, the climate is temperate, arid, subarctic. So we are getting those results here. Or you can do things just in like SQL or in any typical query language. We can add some additional fields and sort the results based on those fields, for example. So for this one, though, the auto-generated schema does not have this kind of additional arguments. So we need to go, we can change the this auto-generated schema to say that I'd like to use this built-in argument called order by with characters. The value will be a ID. So you can make these kind of updates to the auto-generated schema, and then you would be able to use these kind of additional operators. So the results are now the characters returned are sorted by their height field, for example. And again, just to make the point, if I go to the query plan, you'll see that Stardog was able to translate these filters we are writing at the GraphQL level to whatever that data source supports for those filters. So we have all these mappings for different backends. And at this point, I'd like to talk a little bit about what it means to add some additional inference capabilities. So we can make transformations to the data on the fly by adding some rules on top of the base graph model. I'll show you some examples here. We have to use the RDF syntax for defining these rules, which is, we don't yet support writing these rules in GraphQL syntax, but we are thinking of adding this feature in the future. But what you can do with these things is, for example, we have starships and they have length information, but the data is not very clean. It's not numbers, for example, everywhere. So we can write these rules to do some cleanups, make sure we attach some units associated with the field so that, for example, we know the length is represented in meters. And then we can have additional rules that says, if you have a certain kind of starship where the length of the ship is in certain range, then classify that ship as a subclass of the starships. We were looking at those different subclasses in the model. So we can automatically classify the starships based on their lengths using these rules. And what this means is, I'll switch to, let's see. Okay, so for example, this query is now asking for frigate kind of starships. So the rule says frigate is something where the length is between 200 and 400 meters. So we don't have this frigate information directly in the graph, but by enabling reasoning, we would be able to use these rules coupled with this length information in the database and be able to return the matching results from the database. So now 2 of the starships were identified as frigate. I guess I can add the ship length to oh, but we haven't added the ship length into our model, so we can only get the we are getting a validation error as a result. So I need to go back and change my GraphQL schema. But even without changing it, let me again briefly show you the query model. Again, it might be too hard for you to read what's going on here, but the point is, this query is now using those inference rules I created. It's finding the length of the ship, applying those transformations and those filters we have defined, and returns the relevant results. So this is quite powerful, as you can see, because we don't have to change the data. We just add our business logic as in the form of rules, and suddenly our queries returns the relevant information to us. Maybe to show you kind of the next step in this, I'll go to Explorer and connect to this other database, which has, so this is again another Star Wars based example, but the domain here is much more complicated. And here we also have different models, different rules defined, showing different point of views. So, for example, we have a set of rules defined from a Rebel Alliance point of view. If I select this Rebel Alliance view and apply it here, I can, for example, let me find the frigate class here. So I can search for frigates. It will return two things, but then I can switch to the Empire model, which actually has different rules for classifying these ships. And suddenly the results look different, because now whenever we are querying with the Empire view, we are kind of putting a new lens over the graph. You'll actually see here the length of the ship is 300, but the Empire, not surprisingly, uses the imperial system. So our rules automatically translates the meter into yards, and then the classification rules use the imperial system to do the classification, and the Empire has different views. So, I mean, the point here, obviously, Star Wars is fun to play with, but the general point we are trying to achieve here is, when we are at a large enterprise, this data coming from different sources, everybody has a different point of view. You go to a large enterprise, even a seemingly simple question like, what is a customer? How do you define who is a customer? You'll get lots of different answers. So here with these views, we apply these different lenses over the graph. And yeah, maybe just to make the point about the GraphQL integration, I've been showing you everything through Stardog Studio, but you can obviously use any GraphQL tool to query the system. So here I'm using the graphical. I can run my queries against Stardog to that Star Wars database and get the same results with any GraphQL enabled system, including the reasoning and so on. So I can use these query variables to choose different lenses, apply the lenses to these queries, and return the results accordingly. Okay. At this point, I think I'll just switch to slides if there aren't any questions. To kind of wrap up. Let's see, my slides are here. Okay, so just to emphasize, what are we achieving with the graph, the knowledge graph platform here? We have the virtualization capability, so we are not copying the data, but still being able to query it without writing these resolvers manually. We are using the semantic graph and declarative mappings to map our graph model to the external data sources. And we are also using inferencing to add additional information to the raw data, add business logic that can be different based on whoever is querying the graph. And all these features work very nicely with GraphQL, as you have seen. I can run Sparkle queries against these things, but if for the developers who already know GraphQL, it's obviously much more easier to use GraphQL to query the graph with all the reasoning and inferencing capabilities directly exposed through GraphQL as well. And end-to-end, everything is based on standards. So it's the GraphQL standard, there's the RDF standard as well. Like the virtualization capability that we have in Stardog is unique in some sense, but if you develop an application using these GraphQL queries, you would be able to move it to a different, completely non-graph based GraphQL architecture as well, all the GraphQL queries would be working with your GraphQL schemas as a result. And that's all I had for today. So if there are any questions, comments, feedback,